Welcome to Mastering Organic Chemistry, a YouTube channel with Professor László Kürti. First, I would like to say a few things about myself, my education, my training, and as well as my interest in teaching the next generation of organic chemistry. I was born and raised in Hungary, in Europe. Hungary is a small country of about 10 million people located in the almost geographic center of Europe. I grew up in northeast Hungary in a city called Miskolc, and this is where I got my elementary school and secondary school education. Then I moved to eastern Hungary, to the second largest city of the country called Debrecen, where I got my diploma in 1998. At that point, I decided to leave Hungary and move to the United States to further my education. So in 2001, I obtained my Master of Science degree in synthetic organic chemistry at the University of Missouri, Columbia, with Professor Michael Harmata. Then, in 2006, I moved to the East Coast, to Philadelphia, and joined the research group of Professor Amos B, and under his guidance, I obtained my Ph.D. in 2006. Right afterwards, together with my wife, we moved to Cambridge, Massachusetts, and joined the research lab of the 1990 Chemistry Nobel laureate Professor E.J. Corey. Each of us spent 3 and 4 years respectively in this group, working on a number of synthetic projects as well as book projects. In 2010, I began my independent career at the UT Southwestern Medical Center as an assistant professor. This is located in Dallas, Texas. In less than 4 years, I got the opportunity to join the chemistry department of Rice University in Houston, Texas, as an associate professor. So on June 1st, 2015, I set up my brand new modern lab in the Bioscience Research Collaborative building of Rice University, or as we refer to it, the BRC. This is the BRC from a bird's eye view. This is a 10-story, beautiful, modern research building that is home to more than 400 researchers. My lab is located on the 3rd floor in an open concept, and we have 13 hoods, and this entire lab encompasses about 4,000 square feet. We have all the modern synthetic tools and equipment, analytical equipment, to carry out cutting-edge organic synthesis project. Now, a few fun facts about myself. I really like traveling for both business and family fun, and I especially enjoy getting to know different cultures and people. To date, I visited 38 countries on 5 continents, and I had the privilege to visit many exciting places, as you can see here, and the hope is that the number of these exciting places increases over time. Since 2009, I have delivered about 200 invited lectures and seminars all around the world, and this means that just since 2015, I have given more than 100 invited lectures in academic institutions, symposia, conferences, as well as at pharmaceutical companies. Of course, all this traveling requires flying, and even though I don't pilot planes, but I am an aviation enthusiast, so that's a second hobby of mine. And I have taken more than 600 flights. They covered more than 1.4 million miles, and all these hours on the planes amount to more than 4 months in the air. I also like to take group members to a variety of conferences. We have already visited a number of excellent conferences in the US as well as abroad. And in the not too distant future, we're gonna travel to even more interesting conferences and symposia where my students and postdocs get an opportunity to present their research finding. I am truly devoted to education, and I hope it convinces all of you that I am co-author of 3 award-winning and best-selling books. The first one, I have co-authored it with my wife, Dr. Barbara Zacko, when we were still graduate students at University of Pennsylvania. This book, The Strategic Applications of Name Reactions in Organic Synthesis, or as many people nowadays refer to this, SENROS, as the abbreviated name, has 250 name reactions presented in 4 colors. And we focus on the mechanism and the synthetic applications, and there are 10,000 references that are listed at the end of the book. As we move to our postdoctoral studies with Professor E.J. Corey, in 2007, we co-authored a book on molecules and medicine that looks at the over 100 important molecules that have had a fundamental and profound impact on the health of humanity. So I highly recommend all of you who are interested in history and the structure of these medicines and their mechanism of action to take a look at this book. And in the final year of my postdoctoral stay in 2010, I co-authored the book with Professor Corey on enantiomer selective chemical synthesis, where we look at the various methods, the logic of the synthesis, as well as how these transformations are put into practice. And this book lists more than 5,000 references, so the reader gets a good overview of this emerging and rapidly expanding field. Now, in my independent lab, we of course continue to focus on synthetic organic chemistry. This involves development of new methods and then putting these methods to use by synthesizing bioactive molecules as well as moderately complex natural products. And through collaborations, these synthetic products are evaluated in biological assays. You can read more about the projects we pursue in the lab and our collaborators on my group website. Now, my research lab is structured in the following way. We focus on reaction discovery. This includes the development of novel catalytic reactions, synthesis of new reagents, the screening of catalysts and ligands, and rational catalyst design. Then we employ these reactions for the synthesis of structurally complex molecules, as well as active pharmaceutical ingredient building blocks. And wherever possible, we engage in collaborative projects. This includes fundamental organic chemistry and theoretical type of collaborations, as well as more applied research, such as synthesis of building blocks for more complicated structures, such as polymers or even compounds for analytical applications. And most recently, my group has started a new research area, which is the synthesis of energetic materials. So just a few highlights. We are working on the synthesis of novel polynitrogen compounds, which have ultra-high energy density, as well as we make high nitrogen containing materials, as well as high energy fuels. My research program has 3 main thrust areas. The first is the development of new chemical tools for sustainable organic synthesis. rapid and efficient synthesis of heterocycles, as well as introduction of oxygen and nitrogen into non-functionalized molecules. So, of course, there are many aspects of this research program, but a few highlights. We develop methods that prepare CC, CO, and CN bonds in a direct fashion. We are looking at new ways to induce and transfer chirality. We are looking to invent new reactivity and exploit novel reactive intermediates. Wherever possible, we develop and apply environmentally friendly reagents and catalysts. Now, in the last 5 years, I think it's pretty clear in my research program that we have been developing methods that either minimize or completely avoid the use of transition metals and their complexes. We do this for a variety of reasons, and just a few important reasons involve that, especially in the pharmaceutical industry, getting rid of transition metal residues is an expensive task, and these toxic residues need to be removed before compounds can be used in clinical trials, especially in humans. And from a synthetic chemistry perspective, it is exciting to think about new ways how we can replace transition metal complexes and come up with new mechanisms to accomplish the same task as these complexes allowed it in the past. Because of this transition metal free work, we of course engage in the design and synthesis of reusable organocatalysts. In terms of teaching, besides mentoring graduate students and postdoctoral fellows, I teach organic chemistry classes at both the undergraduate as well as the graduate level. I pay special attention to convey the strong fundamental knowledge to my students, because they will need it to succeed in other classes such as biochemistry, molecular biology, and they need to have a very strong understanding of organic chemistry to continue to be successful and then build on this knowledge even later in their careers. Now, it is not a surprise and a secret that organic chemistry as a subject tends to have a bad reputation among other undergraduate students, because many have the temptation just to memorize the material without understanding it. So the subject becomes too difficult to study for, and it takes too much time. Therefore, I pay a lot of attention to structuring of both my lectures and discussion problem-solving sessions so that critical thinking and understanding and the application of concepts is emphasized. I also follow the same approach when designing problems in quizzes and exams, so that memorization alone is not rewarded. Students need to use a combination of concepts and their problem-solving skills in order to succeed. So in summary, my overarching teaching goal is to provide the students with lifelong skills and strategies for solving problems of variable complexity in a systematic fashion and with confidence. So thank you for your attention, and hopefully you will enjoy the short videos that will be uploaded to this channel.